Hello students, so continuing with the last lecture where we were discussing about the branch group of 8085 microprocessor instruction set. So the next instruction under this branch group is RET instruction. So as I've told you, in call address or call conditional address instruction, what used to happen, whatever address is mentioned along with the call, that instruction used to get stored in the program counter, and the next instruction address is gets stored in the stack memory. In RET instruction, what will happen, the address in RET instruction, what will happen, the address which was stored in the stack memory, means which address I'm talking about while performing the call instruction, which address used to get stored in the stack memory. The next instruction address used to get stored in the stack memory. So that next instruction address will get retrieved in the RET instruction, and that address will get stored in the program counter, and the program execution will start from that loaded address in the program counter. So let me explain with an example. Suppose before execution of RET instruction, suppose the stack pointer was having the address 2SFD. So here I have shown 2SFD here. This is the stack memory 2SFD, and the program counter is here. So what is happening after execution of this instruction, whatever address is stored in the stack memory, that address will get stored in the program counter after the execution of this instruction. Means which is this address? This address is the address next to call instruction. Next instruction address of the call is this address which was stored during the time of call instruction, and in RET instruction this address will get retrieved and stored in the program counter. So how it will get retrieved and stored in the program counter? Initially the stack pointer was pointing here. So stack pointer, where the stack pointer is pointing, this lower byte address will get stored in the lower program counter, and then the stack pointer will get incremented by 1, and it will point towards this 27FE, and the content 62 will get stored in the program counter high, and the stack pointer will get incremented by 1, and it will point to 27FF. So after execution of this instruction, the stack pointer will show the content 27FF, and program counter will have the address that was initially stored in the stack memory, and the program will execute from this 6200. So what is happening whenever you are writing any program? Suppose this is the main program. There are so many instructions in the main program, and now there is a call instruction, call address instruction. So after this call address instruction, there is another instruction. So this instruction address will get stored in the stack memory during the call instruction, and the address that is mentioned along with the call, this will get stored in the program counter, and that subroutine program will get executed. Now after this subroutine program, there is a RET instruction. This RET instruction will bring the program execution or the program control back to the main program from where it was from where the control was given to the subroutine program. So flags affected, obviously no arithmetic or logical operation is being taken place. So flags affected will be no flags will get affected. Number of bytes, as there is no extra hexadecimal number mentioned along with this instruction, so number of bytes will be 1. Machine cycle, obviously it will need 3 machine cycles. How? First machine cycle will be used for fetching the opcode. After fetching the opcode and decoding it, microprocessor will get to know that it has to retrieve the address from the stack memory and store it into the program counter. So second machine cycle will be used for reading the lower byte of the address that is stored in the stack memory, and the third machine cycle will be used for reading the higher byte of the address that is stored in the stack memory. Once the address is with the microprocessor will store that address in the program counter. So all total 3 machine cycles will be needed. How many T states? Obviously it is also an exceptional case where the opcode fetch machine cycle will need 6 T states. So all total and memory read needs 3 T states, memory read needs 3 T states. So all total 6 plus 3 plus 3, 12 T states. Addressing mode here is registered indirect, as address of operand is indirectly specified by the stack. Which operand means here the operand is the address, next instruction address that is stored in the stack memory, and that next instruction address which is stored in the stack memory has to be stored in the program counter. So the address of the next instruction address means the stack pointer address. So what is happening, the operand's address is indirectly specified by the stack pointer in this instruction. Again I am repeating what is happening, what is actually getting stored in the program counter. In the program counter, the next instruction address which is stored in the stack memory, it will get stored in the program counter. So the operand is the next instruction address, but where the next instruction address is stored in the stack memory at this location where the stack pointer is pointing, at this address where the stack pointer is pointing, means the address of the operand is indirectly specified by the stack pointer. So here the addressing mode for RET instruction is registered indirect addressing mode. The next instruction is RET condition. So this instruction will work same as like RET instruction, just the difference is if the condition gets fulfilled, only then the RET instruction will get executed, otherwise the RET instruction will not get executed. This is the format RET condition, but how it is written, these are the RET condition instructions. These are the actual RET condition instructions. Like if you want the RET or the written instruction to work when the carry flag status is 1, so you need to use RC. RC is the RET condition instruction for carry flag status 1. So whenever any condition gets fulfilled, only then the RET condition instruction will work. And again flags affected, since no arithmetic or logical operation is being taken place here, so flags affected will be no flags will get affected. Number of bytes, as you can see there is no hexadecimal number mentioned along with this instruction, so number of bytes will be 1. Machine cycle, it will need, if okay fine, again this is a condition RET condition instruction, sorry. This is the RET condition instruction. So what will happen in RET condition instruction, generally it will need 3 machine cycles, as I have told you. First machine cycle will be used for fetching the opcode. After fetching the opcode and decoding it, microprocessor will get to know it has to retrieve the content or the next instruction address from the stack memory and store it into the program counter. So the second machine cycle will be used for reading the lower byte of the next instruction address from the stack memory, and the third machine cycle will be used for reading the higher byte from the stack memory, higher byte of the next instruction address from the stack memory. So if the condition will gets fulfilled, 3 machine cycles and 12 T states, and if the condition doesn't get fulfilled, it will need only 1 machine cycle and 6 T states. And that machine cycle is for opcode fetch and determining whether the condition is fulfilled or not. Then addressing mode, obviously it's registered indirect addressing mode, because here the operand is the next instruction address which is stored in the stack memory, and the address of the next instruction address is pointed by the stack pointer. So here the address is indirectly specified by the stack pointer, so the addressing mode is registered indirect addressing mode. Stack pointer is a register, obviously, so addressing mode here is registered indirect addressing mode. Next instruction is RSTN. RSTN is same as the call instruction. It is a fixed call instruction. What will happen, as I've told you, in the call instruction, what used to happen, the next instruction address used to get stored in the stack memory, and whatever address is mentioned along with the call, that used to get stored in the program counter. In RSTN, what will happen, the same as the call instruction, the next instruction address will get stored in the stack memory, and here n is representing the number like RST0, RST1, RST2, RST3. So suppose if it is RST4, then the address will be 00, the address will be 0020h. So this is 0020h will get stored in the program counter. Again I am repeating what will happen in this instruction. First, the next instruction address, next instruction means the next instruction of to this RST in the main program. So the next instruction address will get stored in the stack memory, and whatever RST is mentioned, if it is RST4 or if it is RST3, each RST is having an individual address mentioned. So that address will get stored in the program counter. Flags affected, obviously there is no arithmetic or logical operation being taken place, so flags affected will be no. Number of bytes, there is no extra hexadecimal number mentioned along with this instruction, so number of bytes will be 1. Machine cycle, obviously it will need 3 machine cycles. How? First machine cycle for opcode fetch. After fetching the opcode and decoding it, microprocessor will get to know that it is a fixed call instruction and the next instruction address has to be stored in the stack memory. So the second machine cycle will be used for storing the higher byte of the next instruction address in the stack memory, that is memory write. And the third machine cycle will be used for storing the lower byte of the next instruction address in the stack memory, that is also a memory write machine cycle. So 3 machine cycles will be used. So here also output fetch needs 6 T states. So all total how many T states? 6 plus 3 plus 3, all total 12 T states. Addressing mode, register indirect addressing mode, as here the address is indirectly specified by this n cross 8 hexadecimal. So I'll tell you how this number is coming out. So this is all about RST instruction. So we'll start stack instruction in my next lecture. I'm ending this class here. Thank you.